I just want to let you guys know. So what about now looking at the one below? 0 and 1, but now there's a couple tick marks. There's not 0 tick marks, there's not 1 tick mark, this is divided into fourths. Raise your hand if you think the half is here. Raise your hand if you think the half is here. Alright, raise your hand if you think half is here. Raise your hand if you think half is here. Hashim, why do you think 1/2 is here? Alright, so even though there wasn't the exact 1/2 amount of tick marks, we still knew it was there. And same with this one. This one's divided into 1, 2, 3, 4, 5 fifths. So sometimes the tick mark, the 1/2 might not even be on a tick mark at all. For example, in this one, 1/2 isn't here, 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 or here. It's right in the middle. 1/2 would be right in between these two. And we can tell that because it's exactly halfway between 0 and 1. 1/2 is a reference we're going to be using for fractions today, and kind of having that understanding of where 1/2 is on the number line, even if it's not dividedly perfectly into halves, is something that we're going to be working with. So if I had the fraction 5/12, and I was going to mark it on this number line right here, I would, and it's divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I would move over 1, 2, 3, 4, 5 and mark it right at 5/12. And I would even label it. So knowing that, if I wanted to compare it to our benchmark fraction, 1/2, I have a couple options of how I could compare. One option is I could use another number line right above it, the same size, from 0 to 1, and I could mark 1/2 on this number line right here. Raise your hand if you'd like to mark 1/2 on this number line for me. Hashim? So just on the number line right up there, right where you think 1/2 is. All right. And so kind of looking at that reference of 1/2, drawing a dotted line right down and drawing this dotted line up. Do you think 1/2 is greater than or less than 5/12?
Greater.
Greater than? So what would be the comparison statement that you would make? Kind of using these symbols, remember how we talked about that? 1/2 is greater than 5/12. Another way to mark 1/2, instead of using a second number line, is to mark it directly on the number line where we marked 5/12. So who wants to challenge themselves to come up here and try to mark 1/2 on this number line? Come on right up.
1/2.
1/2, right on this number line right here. All right, and how do you know that was 1/2 right there?
5/12 and 6, half 12, and 5/5, just go over 6/12, and if they both divided by 3, yeah, it would equal 1/2.
1/2. Because 6/12 is an equivalent fraction to 1/2, and so he knew that by looking at it. Thank you, you can sit down. By looking at that it was 5/12, he knew that just he had to go one more over to get to 6/12. And kind of like we talked about over there, look at 1/2 is exactly in between 0 and 1, even though there weren't the same number of tick marks. There were 11 tick marks here divided into 12 sections, but 1/2 was still directly in the middle. And so looking at the fact that we understand that 1/2 is greater than 5/12, we also understand another comparison sentence. Can anyone think of another comparison sentence that we can make using this number line, using these symbols? Right here we have 1/2 is greater than 5/12. What would be another option we could have? Say that again? 5/12 is less than 1/2. How did you know that? You don't know? If we knew that 1/2 was greater than 5/12, then does 5/12 have to be less than 1/2? Yeah. So this comparison can go both ways. We can write it 1/2 is greater than 5/12, and we can also take the reverse of that. Knowing that, we also know that 5/12 is less than 1/2. Is there any other comparisons we could write? There's one more. This one's kind of not too fun, but we can also write, and if the symbol's not up there, 5/12 does not equal 1/2. Kind of just an interesting twist, one we haven't thought about. But we know that those aren't the same because we know 1/2 is greater than 5/12, and we know that 5/12 is less than 1/2. So we know they can't be the same value. One is greater than the other. Now we're going to try another problem together, and this one's going to be I'm going to add a little extra step in there. Using what we did with Miss Swanson and Miss Schuster 2 days ago with the factor trees, factoring out a number to plot it on the line correctly. We're going to kind of start with that, factor it down, try to plot it on the line, and then compare it to 1/2 and see how that works out. So if I had the fraction, do you want to pass out the whiteboard? I'm going to pass out whiteboards, you guys, so you can draw your factor trees. And one thing I want to say is when we're drawing factor trees, after you're done, will you not erase your board? So that way I'm going to pick someone to bring their board up and demonstrate their factor tree. And so that way by not erasing it, you'll still have it for me. So looking at the fraction 9/21. What two factor trees are we going to make from 9/21? Yep. 9 and 21. So on your whiteboards, I want to see two factor trees, one for 9 and one for 21.
Can I pause for just a second?
Of course.
Make sure that we can read what you're doing. Don't be in such a hurry that I know exactly why I said it. That we can read the numbers. So take your time enough that we can read. Because otherwise it's really hard for us to tell whether you got it or not.
And then also, once you've factored both of the numbers, look for what the greatest common factor is. Remember, we've talked about that before. And I want you to write the greatest common factor and circle it. Put a circle right around the greatest common factor. All right, who wants to volunteer to put their board, if you want to put your board on the wall, just anyone who's willing to put their factor tree, because I see we have a couple, so why not have a couple extra? All right, so it looks like we believe that the greatest common factor is 3. So the greatest common factor between 9 and 21 is 3. And we did that by we factored. We all have little factor trees, and then we noticed that we had 3 in common. And a couple people went above and beyond. So knowing the greatest common factor is 3, what do I do with that information? What is the next step? Finding an equivalent. How do I do that? What do I do with it? Where do I? But what do you think? What do you think I do with the greatest common denominator or greatest common factor? Christine, make sure you're speaking loud so everyone can hear you. What do we do? Divide the numerator by 3 and the denominator by 3. So what does that equal? 9 9 divided by 3 equals 3. 21 divided by 3 equals 7. So there is an equivalent fraction, and it will be easier to plot on a line. For example, this line. Okay, so here is a line right here. So knowing that we have this fraction, 3/7, I want those Post-its that are at your table, come off on this line right here and mark where 3/7 would be.
That last table needs Post-its again. I put them on the paper.
All right, I'll make sure to give you guys the exact amount of Post-its you need.
That's probably a good idea. Because they were part of the head.
Erin, you have one? Mm-hmm. Here you go, Shane. Alright, so we marked 3/7 at 1, 2, 3 at the third tick mark, and it's divided into sevenths. So knowing that 3/7 is right at this spot right here, I'm going to label it. So if I was going to label a dot that I'm marking on a number line, what would I put? So I want people to know that this is 3/7. What's something I could put? Yeah? 3/7, right? Do I write it way over here, 3/7?
No, because it wouldn't be like mine.
Yeah, 3/7. So that way, if someone was looking at this, they'd say, oh, that dot must mean 3/7. Comparing it to our benchmark of 1/2, we have a couple options that we could do. Remember, we had that separate number line. We marked 1/2 compared, and we can also compare directly on the number line. So looking at this number line, I'm going to re-hand out your Post-its. Actually, I'm just going to, Elijah, would you want to mark on this number line where you think 1/2 would be? No? Can I? Okay, come right up here. Bryce, mark right here on this number line where you think 1/2 would be.